Forgot how to teach. No, we'll make it up. So this is in, let's see, where are we? We are in our chapter 9, going down. Where is it? Here it is. So there's a reading for this. We're going to do chapter 9.1 to sample proportions. So we're starting off with proportions. And what is a proportion? Remember? So we did means and proportions. Means were amounts in the middle, right? What was a proportion? A percentage, right? So these are like the binomial. We're looking at something, a percent failure, percent success. So if you gave somebody a medicine, the percent of people who got better from the medicine, right? That would be, so they're all kind of along those binomials. And these are the 4 different sections. Actually, there's just 3 for us, but we'll look at the proportions first because they're actually the most straightforward. We'll look at 2 examples today, and we'll also look at confidence intervals while we're doing that. The next lesson we'll look at, which will be Friday, will be the difference between means. So we'll go from proportions to means. And then we'll look at 2 different types of means where we know the standard deviation of the population when we don't. So t-test and z-test, just like we did last time. But this time we've got 2 samples. And the only real difference is that we've got 2 sets of statistics to enter in when we go to the calculator. The calculator is going to work very similarly to what we were doing. Okay, so if you kind of understood, we're on the cusp of understanding from the last test, this will all just kind of make a lot of sense, hopefully. And if not, it'll give you a chance to revise that, to learn it and go forward with it. Okay, let me see. Let's go with this. So we're doing 9-1. At Reedley High School, they have, it's called 8-1 for them. So we're going to look at how to perform a 2-sample z-test and t-test as well. But today we're doing the z-test for population proportions. And remember, that was when we had the p hat and so it'll be p1 hat and p2 hat. So we'll have two p hats for samples. And what we're trying to do is apply it to the population. When we finish today, and I don't know, maybe because we've got our longer class time, right? Maybe 20, 25 minutes, we'll look at those 2 examples. You'll be perfectly ready to address questions 1 through 7 in the homework. And if you just focus on it, work on it as a group, I believe you'll get all 7 of those done. And then we'll pick up the rest. I think there's a total of 20 or 30 questions in the homework, but that's for 4 sections of stuff that we'll do. But today, my goal is show you how to do it. Hopefully it makes a lot of sense, and then get you where you can get those 7 questions addressed. And there's multiple parts to them too. The other class has only 5 questions, but again, there's multiple parts, so it's about equal. So here's our first example. We're just going to go through 2 different examples just like this. And we're just going to start off with the study. We have, get my pen going. And part of what you want to do is you want to highlight or underline the important parts. And remember, the things we're going to need, we need the sample size. And in this case, we're going to need number of successes. That's what we put into the calculator. And then we'll be walking through that. So again, if you have your calculators out, you can kind of follow along with the steps. It'll help out. If you start to get lost, maybe just set it aside and see if you follow. I'm recording this, so we'll be able to pull this back up later. But I think you'll see it's very similar to what we've done before. So a study of 200 randomly selected people driving vehicles in Washington. So 200 is what? We randomly selected those people. What part of our statistics is that? That's our sample, right? That's the number in our sample, okay? In Washington, and 250 randomly selected driving vehicles in Vermont, 250 in Vermont. So that's also a sample. So notice we've got 2 different samples. Some people in Washington, where I just came from, and some people over in Vermont, where I've never been. So 2 different parts of the country. Anybody been to Vermont? I hear they got good skiing, but that's about it. Okay. Uh, randomly selected people driving vehicles in Vermont. That shows that 93% of people driving in Washington, 88%, and what are those percentages? Those are proportions, right? That's a proportion. 88%, 88.8% of people driving vehicles in Vermont wear seatbelts. So that's, I guess, what's going on while driving. We're asked then at a alpha equals 10%, so remember that's a significance level, can you reject the claim that the proportion of people who wear seatbelts while driving is the same for Washington and Vermont? So you see now we're able to compare two different samples. Are they the same or are they different, right? So that's what we're asking us to do. So the claim is that the percentage is really the same. Now notice it's different, right? 93 and 88, but statistically, is it about, is it close enough that it'll be considered the same? Can we reject that or not? So first thing is, what is the sample size for Washington? 200. So we'll put that as N1 equals 200. Okay, so that's the first thing we had to pull out of there. How about for Vermont? What was the sample size for Vermont? 250. Okay, and you're going to see that'll directly affect what we put in the calculator. Now, did they give us the number of successes for either of them? They don't, do they? But they give us the percentage. So let's write that down. They gave us a proportion, 93% driving in Washington. So this is 93%. And then 88.8%. So that's 0.888. Okay. And so how can we get the number of successes? There's a calculation we can do from those numbers. Remember, we have a percentage, we have the sample size. How can we get the number of successes? Call this p hat 1, p hat 2. Give you a hint. It's one of our mathematical operations. Addition, subtraction, multiplication, or division. Which one of those? What's that? Not division. So we got down to 3. When you have a percentage and you want to know something, like you want a discount, 40% discount, what do you do to the price? Multiply it. Very good, very good. So what we're going to do is we're going to take 200 times 0.93. Okay, and we could do, again, once you get used to this, you could actually do it inside the calculator. I'll show you that, but I'm just going to do it here. So in the main calculator, we take 0.93 times 200. And that tells us that there was 186 people in Washington who actually were out of that sample, okay? So we come back here. And what's that going to be? That's going to be our X1. So the number of people in Washington that were wearing seatbelts. How about for Vermont? We're going to take 250 times 0.888. 222 people in Vermont out of that sample were wearing their seatbelts. Okay, so you can see, so some questions, they don't give us those numbers because we need those to put in the calculator. We can't put the proportion in because the calculator doesn't work that way. So we need these, and we can put them in simply by this. Okay, so this will be our X2, and that is 2, 2, 2. Okay, so that's it starting. Now let's go to our calculator and do this hypothesis test. So does anyone remember which one of these 4 statistics tools we use for hypothesis tests? Inference. Very good. We're doing inferences. We're taking samples and we're trying to say the population is such and such. Okay, good. Are we going to do a test or are we going to do an interval test? Because that's hypothesis test. We're going to also come back and do an interval on the same question, but we'll see how they're connected. But we're going to start with a test. And what do we have? One proportion or two proportions? We've got two. That's all that's different. We did the one proportions on the last set of stuff. Now we're doing two proportions, and watch how it's just a little bit different. So what we're going to do is, since we've got two proportions, rather than saying that the hypothesis is that the proportion equals a certain amount, we're going to say the difference of the two proportions. So notice they're doing P1 minus P2 equals 0. And that's the only thing you could change is this amount of 0. But what that's saying is that they are the same. And a lot of times that's what the null hypothesis will be, that basically the proportions are so close, they're pretty much the same. The alternate is where we get to put in one of the three, whether they're not equal, whether one is less than or one is greater than the other. Okay. For this particular, and we'll see the second example does something different, but this question is asking, are they equal or are they not, right? So we're just going to go with the P1 minus P2 is not equal to 0. So one, it's bigger or smaller, okay? So we'll go with that one. So that's the only real big difference. And then here we have to enter two sets of data. We have to enter the success in sample 1. So we just, and sometimes this is, arbitrary. Which one's sample 1? Well, we'll just call it Washington sample 1. So the number of successes is 186. This is where you have to be careful. I was doing it myself. I was putting in the sample size for the successes and the other way around. The thing is, the calculator will know that that's wrong because the sample size always has to be bigger. But this one, we're going to put in 186. Okay, for that's the successes. Sample size 1 was 200, so that's why we had to write that out. And then we go on to sample 2. Sample 2 had 222 successes and a sample size of 250. So no, that's all the thing we have to really do. The calculator is going to do all the calculations from here on out. It's even going to give us our answer. And then we have to know what that answer means. Okay. Actually, one more thing, the alpha level, the standard is 5%, but what do they want? 10%, right? So we'll put in our 10% here, 0.10. We go to next, and we're going to get all the answers. That's all we had to do, right? So it's very similar to what we were doing before. Here we go. They calculated the proportion p hat 1, which was 93%, which they actually gave us, but notice how we calculated from there. P hat 2 was 0.888, which is what we had. And then they do what they call the pooled proportion, which is, there's a calculation they can do that basically averages the two and shows that that would be about 90%, 90.666%. Comes up with a Z statistic and a p-value. Now with that p-value of 0.12 and our alpha value was 0.10, do you know whether we reject or not reject? Actually, we could make the decision right now. The p-value, is it bigger or smaller than 0.10? It's bigger. So what does that mean we have to do? We fail to reject, right? So this is the p-value has to be smaller to be able to reject the null. So this one we fail to reject, and if we fail to reject, do we have evidence or do we not have evidence? We don't have enough evidence to say pretty much anything. So we can't reject it. It doesn't mean that they're equal, but it just means we don't have enough evidence, right? And again, we can verify that by going to the next step. And again, this is where, and notice we do have a two-tailed test because we did the not equal. We can zoom in on this. And we can see the gold area, the p-value is more than the rejection area. It sort of went outside the rejection area, so we fail to reject. Okay, We fail to reject. And what we can do here, they're off the screen. So we fail to reject. We can't say that. What I want to do now is I took a snapshot of this. I'm going to put it there. I'm going to show you what happens as far as the confidence interval and how these two are connected. Okay. So again, we would just answer fail to reject on that. We've got it here. We can see it's a fail to reject. What does the confidence interval look like? Well, to do a confidence interval, we do pretty much the same thing, except instead of doing a test, we go to intervals. And what is the confidence interval going to give us? The test gives us the tails. Confidence interval gives us the middle part. Okay, so we'll go there. And notice when we do a two proportions for confidence intervals, we again have to enter the two sets of data. So that's why I copied this here. Number of successes for the 186. Sample size for the first one was 200. The number of successes for the second one, 222. And the the sample size for the second one was 250. Now, if we did a 10% hypothesis test, what would be the confidence interval that goes with a 10% in the tails? What would be the middle section? What's the total that we have underneath? 100%. 100 minus 10 is 90. There we go. So that's how we get this one, 90%. We're going to go with a 90% confidence interval. We go to next. We've got this, and it's telling us the difference between the two is 4%. It's got a Z critical, but watch, when we get to this key part is, when we get to this confidence interval, it's kind of small here, so I copied and pasted it. When you blow it up, look at this confidence interval. It's going from negative 0.002 to positive 0.086. Does that include 0? Is 0 included in this interval? Yes? No? Maybe? Where would 0 be? If on this number line, there's a negative 0.02, positive 0.086. Is 0 in between here, or is it outside of the two? You've got if you go from negative to positive, what's got to be in the middle? So yeah, so zero's got, if you got negative on one side, positive on the other, zero's got to be in there somewhere. It is very close to this end, right? 002, it's probably about right here, but it's inside that confidence interval. So 0 is in the confidence interval. It can't be in the tails. You can't be in the tails and the confidence level at the same time. So this is one way we can connect that the confidence interval tells us this is, 0's in that confidence interval, so it's not in the tails. It's not an extreme. We can't reject it. Okay. You'll see on the next one, it's the reverse, and that's when the 0 is actually outside of it. Okay. So basically, there's a couple questions where they'll ask you to do a confidence interval, and I just wanted you to see it's basically the same of what we've been doing, except you have two samples to enter, and you'll get your confidence interval. And remember, though, this 4%, this 0.042, is the difference between the two proportions. It's not the proportions themselves. Okay, so it's a difference. And since 0 is in that confidence interval, we can't reject it. It's in the 0 part, that there is no difference, is part of the usual part of the middle part, not the unusual part, the extremes. Okay, I'm going to jump down in this presentation. So this is how, again, the same question, but this is how they would have done it by hand. So you can click through this if you want. You can see all the calculations they're doing that our calculator did, coming up with these values. Again, all to see whether we reject or not. They've got their claim. We do it as a subtraction, which is fine. They find it, they do all this. That's what our calculator is doing for us. All we had to do was enter number of successes, number in the sample for 2 of them, and our calculator is doing all this stuff in the background for us. So it's getting that z-value. You could directly compare the z-values, or you could compare the alpha values, which is what we did, right? Okay. I wanted you to see that that's there. It's not something I would expect you to be doing because you've got the NumWorks calculator, which will handle all the formulas. Some of the things that we need, though, is there's 3 conditions to be able to do this test. The samples must be randomly selected. So notice when we read, you'll see they're always saying randomly selected, because if they're not randomly selected, we can't do this. Okay, so that's an important thing. Samples must be independent. So they're 2 different groups. So, people in Vermont are not also going to be people in Washington. So we'll look at what we do when they're not independent, but they need to be 2 different groups. And then the samples also must be large enough. Again, you can take the sample size times the proportion has to be greater than or equal to 5 for all of these things. The ones we're going to present you with will be, but just know this one, maybe have that in your notes. They may have a question about, is the sample size large enough? Well, take the sample size times the proportion, and it has to be greater than or equal to 5. Okay. Notice all our samples were greater than 30 as well, so we were able to do that. Okay. And then again, it comes in with the standard error for when we go with the sampling. But again, the calculator handles all these calculations for both doing the hypothesis tests and the confidence intervals. Okay. I just want to show you what you don't have to do. Okay. So let's do one more example, and we'll see that this equals the other way. And again, for all of these, all you have to do, find the sample size and the number of successes. That's what we'll put in here, and we'll be able to do both the hypothesis test and the confidence interval. Remember, it comes out, if you got it wrong, then it just means it was the other. If you rejected it, well, if that's wrong, then it has to be failed to reject, right? Or if you failed to reject and got it wrong, then it would be reject. And what we can always focus on is that p-value. If our p-value is smaller, what do we do when the p-value is smaller than the alpha value? Is that the one we reject or fail to reject? A, we reject. P is smaller. If our p-value is smaller, we reject. If our p-value is bigger, fail to reject. Okay. Okay, so let's look through this last one. And again, this is a medical deal. Medical research team conducted a study to test the effect of medication to treat patients with post-traumatic stress disorder, PTSD. At the end of the study, the researchers found that of the 42 randomly selected subjects who took the medication, 28 no longer met the diagnosis. I don't know if you call them cured, but they no longer exhibited PTSD. Of the 37 randomly selected subjects who took a placebo, you remember what a placebo is? Did anyone explain a placebo to us? That was like way at the beginning. It's nothing. It's a sugar pill. It's a fake thing to make somebody think they're taking a medicine, but they're not really. Good. So the placebo is just a fake pill. No, supposed to not give any value. However, of the 37 who took the placebo, 12 no longer met the diagnostic criteria for PTSD. Then it asks us at the alpha equals 0.01, can you support the claim that the reduction rate in the diagnostic criteria for PTSD is higher for those who took the medication than for those who took the placebo? Okay, so this one's a little different. We're looking for the reduction rate to be higher. Okay, and see if I can remember this correctly. But so let's go through this. The medication, what was our sample size? 42. Excellent. They didn't give us the proportion, and we actually don't need that because the calculator will get that for us, but did they give us the number of successes? 28. 28 were successfully treated. For the placebo, what was our sample size? Excellent. And what was our success rate? 12. Excellent. That's all we need. We pull those out. We're going to put it in. Now, it's a little tricky here because we need to set up the hypothesis test maybe a little differently. So we go to tests. We go to two proportions, just like we did before, but now it's always P1 minus P2. We really can't change this, that when we subtract that, it would be equal to 0, meaning that there was no difference, right? No difference. This is where we're going to change that the alternative, we want P1, the medication, right, that it's higher than P2. And so if we go with this one, and I was doing this earlier, and we'll see, but P1, if P1 is bigger than P2, right, when you subtract them, you'll get a positive number. Okay, so that's, you kind of got to think through, okay? The higher percentage that took the medication were healed than those who didn't take the medication. Okay. Again, if we get it wrong, we go back and say, oh, we must have it backwards. But so for X1, we do the medication group. There was 28 that were successful out of a sample size of 42. X2, we're going to call our placebo group, and that was 12 that were successful just from the placebo, and 37 was the sample size. Alpha level, they gave that to us as 0.01, 1%. So we'll do that as 0.01. We'll go to next. Let's see if I think we got this right. We did this time. Okay. Partly I was following the book, actually had it wrong, so I had to fix their PowerPoint, but so we got it right. So now we could compare the z value, p-value, right? 0.001. How does that compare to 0.01? Is it bigger or smaller? 0.01 here, 0.001 is smaller. So since it's smaller, we get to reject the claim, which means our medication created more, I don't call it a cure, but it had more success than the placebo. Okay. Placebo is kind of like that psychological effect. You think you're taking a medicine, and so psychologically, you could improve. We've got a lot of power within us. But the medication, it does show that the medication made a bigger effect than a fake pill. Okay. So we get to reject the null, and we have sufficient evidence, we have good evidence that the reduction rate in the diagnostic criteria is higher for those who took the medication. So you could just take it right out of the question. Reject, and we have evidence. Okay. That's all we got to do here. Okay. Now, sometimes in the homework, they'll ask you for these values, and notice it's there. They might ask you for the test statistic. That's 3.03. And remember, that means it's way out to that side. We go to the next. We can look, see, you can't even see it, right? We have to really zoom in on it. But we can see we're definitely in the rejection region. We're completely in the rejection region at the far end. Okay. And I want to show you what happens with what do you think is going to happen with the confidence interval? Will the confidence interval include 0? Not this time. Not this time, because we're in the tails now. We're not in the middle part. Basically, this middle part, the white part, is where the confidence interval goes. So clear this out. So we've got our data here. we've got our result here that we were able to reject the claim that there is a difference, not only a difference, but it's a increase for a higher number for the medication. Again, I'm just going to walk you through one more time and show you how relatively easy this is. We go to intervals to do a confidence interval, and all we do is the difference is we go to two proportions now. And you'll see when we go later on, we'll go to two means, right? That's all the difference is. We just enter in a little bit more information, one more piece of information. So the X bar, or the successes is 28. Sample size is 42. The second group, successes, is 12. Sample size is 37. And then remember, we've got to flip it. If we're doing a 0.01 significance level, what is that for a confidence level? 1% significance is a 99% confidence interval. So they have to always add to 100. We do that. Again, we get these values, which the standard error. We see there is a difference between them of 34%. And when we go to the next one, and again, this time, these are always harder to read. So earlier I copied and pasted it here at a larger level. 0.06 to 0.61, that's a pretty big range, but is 0 in there? No, 0 is lower than 0.06. 0 is outside this confidence interval, right? So it shows you that that confidence interval is showing us the usual. If we're in the tail of a hypothesis test, we're in the unusual region. Okay, so you'll kind of see those connections. So confidence interval does not include it. Does that make sense? And again, if you jump down here, it will take you and it will walk you through the same thing, but with all the formulas that the calculator is doing. Okay, so what we're focusing you on is to get the statistics, number of successes, sample size, get those in there, get the test set up correctly. Again, subtracting proportion 1 from proportion 2, and then figuring out whether it's not equal, greater, or less than, running, and then being able to tell whether you reject or fail to reject. Okay, so those are the two things. Just like we were doing before, all we've added is now we've got a second sample, but it makes it more interesting, right? Because we can now compare two different groups, see if there's a difference. And with medication, we can see, does this medication make a difference or not? And we'll be able to do the same things with the other ones. What we'll actually get to is when we do the means, you can also do a pre-test, post-test. So you could do we'll see some questions where we've got a weight loss program, and this is before and this is after. And so we can test the effectiveness of treatments. This is what research is all about. Okay. So let's see, how long did that take us? A little bit longer, about 20 minutes, 30 minutes. What I'm going to ask you to do now is focus on doing the first 7 questions. At least get started. I'll tell you what, if you can get me the first 3 questions in homework 9.1, I'll be happy. If you could get them all 7 done, I'd be even happier. But then the other thing you can work on, once you get at least 3 of them done, work together, test corrections or other homework. But get me 3 questions from 9.1 done, because that's going to cement it in. You'll be owning it after that. Okay.